Hi, good morning. My name is Neil Daswani, and I'm going to be talking about what every software engineer needs to know about security and where you can learn it. This talk will be made available on Google Video on our public website, so please do not ask me any Google-specific questions. I'd be happy to take those after the talk. Let's see. So I guess I'm just going to get things underway. Thank you so much for turning up bright and early at 10 a.m. One question that I sometimes ask myself when I look at press releases from time to time is whether or not the sky is falling. Major tech websites like CNET dedicate an entire section of their website to threats and vulnerabilities, and they're filled with new articles every single day. I thought what I might do is talk about a couple of incidents that have occurred relatively recently. In March of this year, a company by the name of TJX, which owns a number of retail department stores, including TJ Maxx, Marshalls, they basically publicly acknowledged that they were hacked late last year. The hack consisted of a number of cyber criminals parking their cars outside the retail department stores. And what they would do is they would collect data packets that were going by on the wireless network. It turns out that some of these department stores used Wi-Fi to transmit information from their point of sale to their back-end servers. And the encryption was done with WEP, the Wired Equivalency Protocol, or privacy protocol rather, which has been known to be insecure to the security community since 2001 or 2002. In any case, the bad guys kept these cars parked out there for significant amounts of time, and they were able to aggregate over 47 million credit card numbers. Some of the credit card numbers date back to transactions that were made in 2002. So that's pretty darn bad for the community as a whole. There's an FTC investigation that's taking place. There are about 300 banks that have gotten together to file a class action lawsuit against TJX. So that's one example of a recent hack. About 2 years ago, there was also a hack against a company called Card Systems. Card Systems is a credit card, or rather was a credit card payment processor. When you swipe your credit card at a point-of-sale terminal, that credit card number goes to an acquiring bank, an issuing bank, and a number of other processors on the back end in order to authenticate the number. Card Systems was one of the credit card payment processors. They had a database which had about 43 million credit card numbers in it, unencrypted, and somebody at the company had set up a website which allowed people to enter information into web forms. And so what the attackers did is they took advantage of an attack called SQL injection, in which they entered, not names and email addresses into these forms, but they entered SQL commands, and with just the right tweaks, they were able to get the database to execute those commands. So while there were 43 million credit card numbers unencrypted in the database, they were able to acquire 263,000 of them. What they did is they installed a script on the back-end database that would every day email them a couple thousand. And this went on for about 6 months before Card Systems noticed. Needless to say, Card Systems is out of business. Their assets were acquired by another company. I believe it was CyberSource. The idea, of course, is they wouldn't want to acquire all the liability that came along with this attack, so they just acquired the company's assets. And even though 2005 seems like a long time ago on internet timescales, SQL injection attacks still happen very often. So if you were to just enter the keywords SQL injection into news.google.com, you'll see pages and pages of SQL injection-related attacks. Now, I've chosen a couple data points to talk about here, but the problem is really bad overall. If you go to this website, privacyrights.org, and go to this URL, they've kept a chronology of data theft incidents that have occurred over the past 2 years. In the year 2006, there were over 300 incidents alone, so pretty much every business day there's some new incident. And over the past couple years, there's over 153 million customer records that have been compromised. So given all of this, I hope you can understand why I kind of feel, well, the sky might be falling, and if it isn't falling, it's probably going to happen soon if we don't do something about it. I mentioned SQL injection. How does SQL injection work? Well, you can imagine a traditional website architecture where you have web browsers contacting a web server. That web server is connected to a database on the back end. And you might want to do something as simple as authenticate your users with a username and password. To do so, when the web server receives a username and password from a user, it issues a SQL query to a database saying, please give me the password that corresponds to the username that the user entered. And then it can check whether or not the user indeed entered the correct password or not. Of course, an attacker doesn't need to enter a traditional username and password. An attacker might enter the username quote semicolon drop table users semicolon hyphen hyphen and enter something for the password. Of course, when that username gets substituted into the variable that would be reserved for the username, it would expand out to the following. The quote would terminate the username, the semicolon would terminate the first part of the SQL statement that hopefully would not return any results, but then the rest of the username would make up the remainder of an SQL statement, which could end up killing the user table in the database and resulting in a denial of service attack against the users of this service. The hyphen hyphen is there to just comment out the apostrophe, the final apostrophe that's put in by the application, so that the database doesn't say, hey, this is an error, I won't execute it at all. So this is an example of a SQL injection attack. You might ask, well, is SQL injection getting better? Is it getting worse? Let's see. So I pulled some data off of the security focus vulnerability database, and I've graphed the number of vulnerabilities that have occurred in the first half of the year for 2004, 2005, 2006, and 2007. And on the y-axis, we have the number of reported such vulnerabilities. We can see that up until the first half of 2006, there was a pretty apparent increase. In the first half of 2007, the number did seem to come down a bit. It's unclear to me as to whether or not that's statistically significant. And also, all of these vulnerability databases have different data sets and are reported by different researchers against different types of software products. We'll see more of that. In any case, that's a little bit about SQL injection. By the way, if anybody has any questions at any point, feel free to just raise your hand and interrupt me, and I'll do my best to answer your question. So pulling back a second, SQL injection is just one type of software threat that can occur. It's a specific kind of attack that can be more generalized. In general, SQL injection is a subset of what are called command injection attacks. And very often, command injection attacks are targeted at providing data to an application and tickling the application just right so that that data gets interpreted as control information. These command injection attacks can occur usually due to application programmers either not validating input or not escaping output appropriately. Other similar types of attacks that occur are cross-site scripting, in which somebody can provide an HTML snippet or a JavaScript snippet to a website. That website will will store and or echo that injected HTML or JavaScript to another user, and that may result in stealing the user's cookies, a phishing attack, or worse. So that's cross-site scripting for those of you that haven't heard of it. And buffer overflows is also a command injection type of attack. I assume everyone's heard of buffer overflows. Raise your hand if you have. Yes, wonderful. Okay. So in a buffer overflow attack, it is a command injection attack. In some buffer overflow attacks, the attacker sends shellcode into a server, modifies the modifies the return address so that the attacker's shellcode gets executed, and basically injects a command which gives them a command shell. In other buffer overflow attacks, you can send in an appropriate return address so that you can run code of your choice that's already on the server. So you don't always need to inject the commands. You can just tell it to run the commands of your choice that are already on the server. So that's a little bit about some common command injection attacks that can result due to bad input validation. I took a look at from the same database, the security-focused vulnerability database, kind of pulled back and tried to understand at a high level what kinds of attacks are getting worse, what kinds of attacks are we doing better against. Before I start talking about this information, I just want to put out a disclaimer. The categorization here might not be perfect, and in some cases, a vulnerability might fit under one of these categories, and in other cases, it might fit under another. But at a high level, if we look at all input validation bugs in the first half of 2006 versus 2007, we can see that they're about the same. On the other hand, the number of security vulnerabilities due to design errors is going up. There's many type of design errors that you can make when building an application. A common one might be there might be some way to get around your code so that the user doesn't have to authenticate, and that would be an example of a design problem. Another example of a design problem is if you just look at the design of TCP. In the original design, it was possible to send in TCP SYN packets. The server would, of course, allocate descriptors for potential client connections with each of them and end up maxing the server out of those descriptors, resulting in a denial of service attack. So that's an example of a DOS attack that resulted from a protocol design error. Those seem to be up in the first half of this year. Attacks due to boundary condition problems, buffer overflows can fit in that category. And actually, in this set of data, buffer overflows were categorized under boundary conditions as opposed to input validation, basically because when a buffer overflow attack occurs, it's usually because the programmer forgot to check the size of the input or forgot to check exactly how the data in the string is being indexed. And you can index on either direction to try to tickle the server into doing funny things. Attacks due to boundary conditions are up. Attacks due to bad exception handling are also up. An example of an attack due to bad exception handling, I was auditing an application a couple of years ago prior to coming to Google, and it was a web application. It had this interesting bug where, well, what the server would do is it would send you back a cookie once you authenticated. And if you simply didn't send back the cookie to the server, what would happen is the application, for some reason, needed to assign some session ID to continue processing. So what it would do is if you didn't provide it with a session ID, it would decide to go ahead and use the session ID of the last user that logged in. So all I had to do is kind of sit around and wait till the administrator logged in and then send a request which didn't have a cookie, and I would get the administrator's cookie, which would give me all the administrator's privileges. So such attacks fall into the category of bad exception handling. And we can see those are also up in the first half of 2007. Access validation issues, it's hard to tell whether or not there's actually been a real increase. So that's kind of high level where we are in the first half of this year based on the stats from the security-focused vulnerability database. So I took those categories and I kind of drilled down and looked at the top specific vulnerabilities as opposed to the categories, and came up with the following chart. On the x-axis, I have the different vulnerabilities: SQL injection, cross-site scripting, denial of service, and buffer overflows. And on the y-axis, I have the number of reports made to the database. for those. The orange bar is the number of vulnerabilities in the first half of 2006. The purple bar is the number of vulnerabilities in the first half of 2007. And we can see the slight decrease in SQL injection, which we're not quite sure is statistically significant. Based on the information in this particular vulnerability database, it looks like cross-site scripting is down. And it looks like denial of service and buffer overflows are up. So that's what we learned from this particular vulnerability database. But what we'll see is that not all vulnerability databases necessarily agree. So I pulled out some statistics from the MITRE vulnerability database. And started initially, just looked at a report. There was a very nice report online. I'll provide the link. I'll provide you a pointer to the link by the end of the talk. But they did some very nice work where they looked at the number of security vulnerabilities in products put out by OS vendors. And what we see from this graph between 2001 and 2006 is that the number of buffer overflows being reported is still increasing significantly. So even though buffer overflows have been known to the security community for the past 25 or 30 years, the number of such vulnerabilities that we're detecting is still increasing. And then there's a number of other vulnerabilities that we see. If we look at MITRE's data for across all software products, as opposed to just those put out by software vendors, they report that up until 2006, cross-site scripting is increasing, PHP include attacks are increasing, SQL injection attacks, as marked by the upside-down triangles, is also increasing. And then there's other attacks due to buffer overflows and denial of service that are also increasing, although looking at the data overall, it seems to disagree with just the types of vulnerabilities that OS vendors are having to deal with. So given all of this data, what are the real takeaways? Well, I think it really depends upon what kind of software you're looking at. Depending upon what kind of software you're looking at, what the threats are, you're going to see different kinds of vulnerabilities be more prevalent. But overall, the number of detected vulnerabilities is increasing. And I don't know if this is just because we're spending more time looking for vulnerabilities, or whether people are actually writing more bugs into the code. While there are some discrepancies with regards to which exact types of vulnerabilities are being detected the most, the big four seem to be the same, regardless of which vulnerability database you look at. Cross-site scripting, cross-site scripting, command injection, memory corruption, and denial of service seem to top the list. And by the way, when I lay out these broad categories, I've grouped kind of sub-attacks into the categories. So cross-site scripting, cross-site request forgery, cross-site script inclusion, they all fit into cross-site scripting. SQL injection, PHP includes, I group them under injection. If you look at the data in this way, then what you'll see is that these four end up being pretty prevalent regardless of which vulnerability database you look at. So given that these are the vulnerabilities that we're seeing, let's ask the question, what does every engineer need to know about security? Well, you might categorize it as follows. I'd say that every engineer, every software engineer should know about secure design. So in the same way that we learn about object-oriented techniques to help us achieve reusability and extensibility, it's important for all of us to understand secure design principles, like the principle of least privilege, fail-safe stance, how to secure the weakest link, etc., so that regardless of what vulnerabilities we're seeing on a particular day or in a particular year, when we're designing new software, we'll be able to figure out what the appropriate threats and appropriate defenses need to be, regardless of what's happening at any given point in time. So secure design, I think, is an important piece of what every engineer does need to know about security. Aside from secure design, it's important to be familiar with the large variety of technical flaws that can result in attacks. So it's important for companies that build web software to be very familiar and very proactive at dealing with cross-site scripting attacks, cross-site request forgery, cross-site script inclusion, etc. These each of these technical flaws can be used to accomplish a different set of attacks. So you can use cross-site scripting to bypass authentication. You can use cross-site scripting to do data theft. You can use it to steal cookies, for instance. So these are kind of like the causes, and these are the effects. The causes are, I've mentioned most of these, but I haven't mentioned a couple. So I mentioned injection, directory traversal. You can tickle web servers by accessing URLs if you throw in the right set of characters, dots, slashes, etc. You can basically try to break out of the web server's document root and access other files on the file system, or even potentially access other files in the web server's document root that you're not supposed to be able to access. Race conditions. Race conditions can result in security vulnerabilities. A common example is time of check versus time of use types of vulnerabilities. The way these types of attacks occur is at some point the software checks whether or not you're authorized to access a particular resource, say a file. That file could be a symbolic link to something. And if there's too much time that expires between the time that the authorization is checked and the time that the resource is used, what could happen is the resource can change underneath. So the attacker could get the symbolic link to point to something else. That's an example where a race condition can result in a problem. Memory corruption, buffer overflows, integer overflows all fit under that category. So these vulnerabilities can lead to a wide variety of attacks that every engineer should be familiar with. So the question is, where do you go to learn all this stuff? Well, initially, you might think, oh, you could just go to the universities, and when you come out of school, you might be educated about such things. So to see whether or not that's the case, I typed a couple keywords into Google. I said top CS programs, and the following webpage at U.S. News and World Report came up. Now, there's a lot of good computer science programs out there, and I wouldn't just necessarily take U.S. News' word for it, but I thought it might be good to just look at the curriculum in a couple of these universities. So I'm not picking on any university in particular. In fact, what I'll illustrate is that some of the issues here are applicable to pretty much all universities that teach computer science. So I looked at CMU's web page and their curriculum. My hope is that they just forgot to update their web page, but what I found is that in order to get a bachelor's degree in computer science, you have to take this set of courses. So you have to take some programming courses, you have to become proficient in C and Unix, you have to know data structures and algorithms, and those are the set of required courses. So it doesn't seem that learning security is required to become a good computer scientist. Let's see, at this particular university, one thing that was a little disappointing is that security was not even listed as an elective, as one of the electives after you take this set of courses. So that's things at CMU. At MIT, MIT is a great school. Ron Rivest, together with Shamir Nadelman, developed the RSA encryption algorithm out of MIT. So they produced a lot of great technology. They had the following objectives for their undergraduate program. Objective 2 states that students will develop a professional understanding of electrical engineering and computer science so that they are prepared for immediate employment. So to an extent, it's important to know about security when people graduate because they join companies, they end up writing code, that code gets released on the internet, and sometimes their code ends up being talked about in press releases when the code gets hacked. So I think it is important to focus on security if, in fact, the goal is to prepare students for immediate employment. Another goal is students will develop an understanding of the importance of the social, business, technical, and human context in which a process or product being designed will work. As we know, security vulnerabilities very often not only occur just due to technical vulnerabilities, but due to problems in a software development process. Bruce Schneier is often quoted. with regards to security being a process and not a product. So anyhow, this is the objectives that MIT laid out. I looked at their curriculum, and if you want to get a bachelor's degree in computer science from MIT, you can specialize in one of the following three concentrations. You can decide to specialize in AI, computer systems and architecture, or theoretical computer science. For each of these concentrations, there was a particular required header course and then a bunch of electives, which is kind of nice because students get a lot of flexibility in what they decide to take. I looked for where security fit into this curriculum. And where it fit in is it seemed that for the computer systems and architecture engineering specialization in the header course, in the last 2 weeks of the course, there were 4 papers that students were required to read about security, which I thought was great. They learn about buffer overruns. They learn about why cryptosystems fail, great paper by Ross Anderson, focusing on some of the non-technical reasons that security fails. It focuses on worm propagation type issues, and it focuses on our own Ken Thompson's reflections on trusting trust. So I was glad to see security being covered as part of the required curriculum at MIT. But I think that one might ask the question, do we need to provide more preparation than just these 4 papers in order to prepare students for immediate employment? Let's see. Another kind of caveat that I just wanted to mention is, I'm kind of looking at the undergraduate programs, but these schools have, quote unquote, the top graduate programs in computer science. The reason I looked at these particular undergraduate programs was because I wasn't able to find a listing of kind of the top undergraduate programs in computer science. So this was kind of the next best thing. So anyhow, that's what we see at the universities. What's my point here? I think the point is summarized very well by Dr. Zvi Galil, who provided this quote on the inside of a book that I recently published. It says, "It has been too long that security has not been part of the required coursework for bachelor degree computer science candidates, and we are seeing some of the effects. Software security vulnerabilities plaguing electronic commerce, resulting in data, identity, and monetary theft, as evidenced regularly in the press." I think it would be great to have more focus on security in preparing our undergraduates, simply because a lot of the folks that graduate out of these programs end up making up the army of software engineers that are powering some of the most important businesses on the world. So where else can we go to learn more about security? I'll talk about some courses, some certification programs, some books, and some websites and organizations where one can go to learn more. I have to mention up front, of course, that this list is by no means comprehensive. If you know of other good resources, please feel free to drop me an email. Just type my last name into Google, enter Daswani into Google, and my email address should come up. I'm more than happy to incorporate other courses, certifications, programs, books, and websites that you recommend. So what exists in the way of security courses? Pretty much every major university website that I was able to go to listed upper division courses in cryptography, which I think is great. Cryptography ends up being a very important component of building security systems. It usually ends up, not being the biggest component, but nevertheless a very important component, so that you could achieve certain security goals. There's also a number of security courses that are focused on system security. So for instance, CS 155 taught by Dan Bonet at Stanford is an example of that. UC Berkeley has made CS 161 available. These types of courses are great. There is a more comprehensive list of these types of courses at Avi Rubin's website. I encourage you to check it out. Google also offers some courses in the area of security, and there's more to come in that area. Please contact Mike Wiasek if you're interested. So that's one place you can go to learn more about security. Another option is various certification programs. So I'll talk about some certification programs that currently exist and try to talk a little bit about the pros and the cons. Because security information is not covered as deeply as it could be in undergraduate curricula, various certification programs have popped up. One is offered by Stanford. These courses, so the certificate program is made up of a number of courses. It can be taken online or on campus. If you take them on campus, it's kind of 1 week, very intensive, focused towards professionals. They actually have an offering coming up from July 23rd to 27th. In the interest of full disclosure, I help provide some guest lectures for this program. It requires you to take 3 core courses and then some electives. And in addition to the lectures in the core courses and electives, some of the days are focused on hands-on labs where you actually spend time attacking a test system that's been set up. So you actually do cross-site scripting, cross-site request forgery, SQL injection attacks, so that you can really get into the mind of the bad guy, and then you spend some time building the defenses. If 1 week is kind of too much of a commitment, there is a more foundational certificate also available. If you're interested in this or actually in any of the course offerings, talk to Stephanie Chiang at NGDU. She'd be happy to help you get signed up. As an employee at Google, part of your benefits involves involves covering courses at I think all of these avenues that I'll describe. So just talking a little bit more about the certificate program at Stanford, it's very, very focused on software security. So the core courses involve how to use crypto correctly, how to write secure code, how to design security protocols correctly, and then there's a number of electives relevant to web companies. There's a course on securing web applications. They also offer a yearly emerging threats and defenses. So if you want to kind of keep up, are phishing attacks getting worse? What are the new threats that are coming up? The emerging threats and defenses can be repeated year to year. So that's a little bit about the Stanford program. There's a number of other certification programs. There's a certification program called the CISSP. It stands for Certified Information Security Professional. It's offered by an organization called ISC Squared. So far as I can tell, ISC Squared exists solely for the purpose of offering this certification and creating an ecosystem and networking opportunities around the certification. To get a CISSP, so before I mention getting one, the CISSP seems to do a good job in preparing people for administrative security jobs and jobs in the government that are related to security. It consists of passing a long multiple choice test. And it's, as compared to the Stanford program, it's much more broad. So whereas the Stanford program, say, focused on software security, the CISSP covers a wide variety of domains, not only involving application security, but involving telecom and network security, involving physical security, involving legal issues, regulations, et cetera. So it's a much broader program. A third security certification program that is in the process of actually just being created right now is called the GSSP. The GSSP stands for GIAC, Secure Software Programmer. GIAC itself expands out to Global Information Assurance Certification. This GSSP certification is fairly new on the block. It's offered by SANS. So SANS has been around for a while. SANS is a very well-known security training institute. They've done a lot of good work in network security, forensics, incident response, et cetera. The certification, while the certification is new, it's offered by an organization that's been around for a while. And the goal of this particular certification is to provide a secure programming assessment. So it is a multiple choice test, and it asks you a whole bunch of questions about finding vulnerabilities in particular code samples or whatnot. The first offering of this will be in August 2007. So that's a little bit about some security certification programs. There's a number of books that I think are useful in helping engineers learn more about security. One that I highly, highly recommend is Ross Anderson's Security Engineering. One of the great things about this book is that it is available for free at this URL, and it covers, not software security specifically, but it looks at security as an engineering discipline, and talks about, in addition to talking about technologies for authentication, access control, et cetera, what it does is it covers lots of different domains. So it talks about security in the banking industry, it talks about security in nuclear command and control systems, and it pulls out lots of interesting examples and case studies. So for instance, in the case of defense, Ross provides this really fun example in which there were two countries that were at war with each other. They both had MiG planes, jets, fighters, and one of the countries wanted to wanted to attack the other, but couldn't get past their IFF systems, their identify friends or foe systems. So what this country did is they provoked the other country to attack them. They sent a couple of their fighter jets. Their fighter jets were broadcasting IFF friend or foe signals. What they did is they took those signals and they just they instrumented their own fighter jets to echo those signals. So their own fighter jets were able to pass right through the other country's defenses at the exact same time that they were being attacked. And they were able to successfully achieve their goal. So that's an example of some of the things that you'll see in Ross's book. Another very good security book is Gary McRoy's and John Viega's Building Secure Software. Some people refer to this as the classic text in the area of software security. It talks about software-related vulnerabilities like buffer overflows. It talks about some of the challenges in achieving security, both in open source software and closed source software environments. It was really one of the first efforts and initiatives to write down any and all information related to software security at the time. This was about 2001. And a lot of the information in the book is still very, very relevant, so I recommend it. Gary McRoy has gone on to help co-author a number of other books. He published a book together with another co-author, Hoglund, on exploiting software, and that kind of takes the hat of the attacker more into account. So it basically teaches you to attack and exploit existing software, whereas building secure software focuses more on the defenses. Gary's also published a book called Software Security. That book focuses on risk management. It focuses on architecture for security. It focuses on how to incorporate things like static analysis tools in your software development process. And so those are some other very good resources. Another security book that came out recently, one by yours truly, came out in February of this year, entitled Foundations of Security, What Every Programmer Needs to Know. This I co-authored together with Christoph Kern, who's a Googler on the security team here, and Anita Kesavan. This book focuses on secure design principles in the first third of the book, the kind of what principles do you need to know so that you can fight vulnerabilities yourself should new situations come up. The second third of the book focuses entirely on web application security. It focuses on how to construct attacks, how to construct defenses, and then the last third of the book rounds it out with an introduction to cryptography, the goal being to enable you and arm you with enough information about crypto so that you can have a good, fluent, reasonable conversation/debate with security professionals when designing and developing and deploying products. So if you're interested in this book, you can actually pick up a copy from B46 and RA or B46 284. I also have a couple copies out here up front, which you're welcome to. Let's see, if you are interested in getting involved in helping to teach security courses to your team or to other organizations that you work with, There's a set of free slides that are available at learnsecurity.com. All the free slides basically correspond to the book chapters, chapter by chapter, so that we can help get information out as soon as possible without everyone having to spend a lot of time on course development. Of course, people are welcome to tweak the materials as per their needs. A fourth book that's actually coming out is Hacking Exposed Web 2.0. This focuses on attacking Web 2.0 type products. So if you're in the business of building next generation web interfaces, next generation web tools in general, this would be a great book. Rich Cannings, our own Rich Cannings from the security team here at Google, is a co-author on this book. It's available for pre-order on Amazon. Let's see, the final security book that I want to mention is the Secure Programming Cookbook for C and C++ by Viega and Messier. This book is, it's pretty thick, and the thing that I liked about it is it had a lot of examples about how to use cryptographic libraries correctly. It contained information on how to call the OpenSSL APIs just right. Writing crypto code and code that uses crypto can be very, very tricky. You just get one parameter off and all your security is blown. So it was very good for that. It also had pointers to input validation libraries and just a lot of other good code. So I highly recommend it. If you work here at Google, please contact your security team. Prior to trying to apply anything out of this book, we have some additional tools to help. So that's a number of security books that are available on the market, where you can go to learn more about security. There's a number of websites and organizations. I'm just going to touch on a couple. One is the OWASP, the Open Web Application Service Project. I'm sorry, the Open Web Application Security Project. One of the interesting things about this organization is that they are globally distributed. They have local chapters pretty much in every major city. And so if you're looking to learn more about security, I'd recommend getting involved with your local chapter. They typically meet once every couple months. They usually have a talk by somebody where you can learn more. Let's see. The OWSP also publishes, they're very famous for publishing a top 10 list of vulnerabilities. I'm going to show you some of those in just a second. Two other organizations that I'll briefly touch upon, and two other websites I'll touch upon, is the Security Focus website and code.google.com. So the OWSP, I mentioned that they issue these top 10 vulnerability lists. What I thought might be fun is to look at the top 10 vulnerability list that they put out in 2004 and compare it to the top 10 vulnerability list that they just put out this year, 2007. From the list in 2004, they said, number one vulnerability, unvalidated input, followed by broken access control, et cetera. What we'll see is that over the course of 3 years, some of these vulnerabilities have disappeared for various reasons. Some of them have become more significant, and some new ones have been added. So if we look at unvalidated input is kind of very broad in general, right? Cross-site scripting can happen due to unvalidated input. Buffer overflows can happen due to unvalidated input. Injection flows can occur due to invalidated input. And so I have to admit, I was a little bit confused when I was looking at this, and I didn't completely understand exactly how the categorization worked. But it looks like because unvalidated input was too broad in general a category, it looks like it was dropped in favor of more specific vulnerabilities, which I think is a good thing. Broken access control was number 2 in 2004, but that's now gone. At the same time, there's things like failure to restrict URL access. So this is people trying to, they just put out URLs and they assume because they didn't publish or link to it by anybody else or from anybody else that it won't be found. That's an example of broken access control. But my feeling is that this is a broad category that was substituted with something more specific later on. Let's see. Buffer overflows, surprisingly, are gone from their list, moving over to 2007, which is a little bit surprising. Again, I think this is dependent upon what kind of software you're developing. I'm not quite sure who their target audience is, but if you're working on an operating system or you're working on system software, I think buffer overflows are still a big issue. The number of buffer overflows detected was still rising. Let's see, what else? Okay, so application denial of service, again, broad category replacing something more specific. Insecure configuration management is gone from their list. My feeling is that they may have decided to focus more on software security vulnerabilities. There's still lots of security vulnerabilities that can arise due to having the wrong configuration parameter set. And so again, just because they eliminated this from their list, I wouldn't throw it away. I just don't think it's the kind of thing where you have to change code to fix it. Having correct configuration is still very important. So let's see, what are some of the new things that popped up on the list? Malicious file execution. Cross-site request forgery is a new big one. This is what can occur when, say, somebody already has a browser open and is authenticated into some service, and then they get lured to an evil site. That evil site can include a URL to the other site, like transfer funds. And because the user's already logged in, what will happen is the web browser will issue the request and automatically send the user's cookie to that site. So cross-site, and actually do the funds transfer, even though the user didn't necessarily explicitly authorize it. So I'd look out for cross-site request forgery, very significant. Anyhow, so this is the kind of top 10 list that OWASP puts out there. My hope is that over time, these lists will be constructed more and more scientifically based on data and vulnerability databases that we're seeing. I mentioned the Security Focus website. It's the home of the original bug track mailing list. They have a wide variety of articles, vulnerability reports. They have a number of focus areas, operating systems, intrusion detection, incident response, viruses and malware, pen testing, and firewalls. I encourage you to check it out. It's the kind of thing where you can bookmark the site and read articles, read about the new security threats of the day. Finally, the last website that I wanted to mention is code.google.com. Code.google.com pushed out a subsection of the site, /edu, that focuses on providing information to educators, whether they be at universities, whether they be at companies, free materials that are available for use. Just last week, we pushed out a sample course on web security authored by yours truly with the help of Maggie Johnson. Thanks to her for helping make this reality. It provides a set of lectures, PowerPoints that people can just use out of the box, as well as programming assignments to give people real experience. I think with security, you can learn about all this theory, you can read about vulnerabilities, but until you actually attack some code yourself, until you actually defend your code against some attacks, for me, it didn't really sink in until I went through that process. So this is available. The example that's posted, for instance, provides kids and students of all kinds with a 100-line web server that they can do a DOS attack against and then fix it. We are looking for additional contributors for this website. So if you're interested, please come talk to me afterwards. Let's see. To summarize, I encourage everyone to learn more about security to an extent. If we do our job right, then every engineer will become a software security practitioner. I think we'll always need some security engineering specialists, if you will, but my hope is that we can make most security engineers obsolete and have everyone worry about security as part of their jobs. All of the different URLs and resources that I mentioned is available at learnsecurity.com. Just click on the Resources tab on the site, and it'll bring up a list of all the URLs I mentioned. And of course, if you have any questions or you'd like to get more involved in security education efforts, please feel free to drop me a note, either at my email address or at my website. I'd be happy to take any questions. Okay, plain as mud. Thanks.